Folks, hello. Welcome to week five. This week we are going to discuss chapter 10, which deals with hypothesis testing. And the first thing I want to mention here before we get too deep into this business of hypothesis testing is I want to ask you an important question, or I want you to pay attention to something this week and be able to answer this question sometime during the week through the week five CAT, which is again another opportunity for you to earn your participation points. And the question that I'm asking is, what is the difference between a confidence interval, that which we discussed in chapter 9, and a hypothesis test? And uh, you know, immediately after finishing up the work on uh, sampling distributions and the central limit theorem, we went right into our first study of inferential statistics, and that is confidence intervals. And so, typically, in the course of going through this material, the next branch of inferential statistics is hypothesis testing, and here we are studying that in week 10. But again, I want to make sure that everybody is able to answer this question towards the end of, or towards the middle of next week, say by next Wednesday, to take a shot at answering that. And again, what is a confidence interval? What's the focus of a confidence interval? What is a confidence interval doing? And what is a hypothesis test doing? And they are very different. And I want to make sure that everybody clearly understands. It's like reaching in the toolbox and getting a hammer versus a screwdriver. They're designed to do different things, and I want to make sure everybody can answer that. So let's go to the first. Here's what I want to do. I want to go through a couple of problems for you, and then give you a hint on the last couple questions, which deal with data. I think it's again the bank and bus data that I think we're dealing with in those last two questions. But what I want to do is I want to pick a problem that's similar in each case to the two that you're going to do this week, and make sure that everybody's clear. Because as I said in the introductory message for week five, hypothesis testing is very process driven. And before I read the question, I have taken this little screenshot out of your book that talks about this 5 or 6 step process that you are going to go through in order to complete a test of hypothesis. So I want to focus on that and make sure everybody understands that, again, this is really a very process-driven a technique in inferential statistics, and make sure that we can demonstrate each of these in a couple of examples. So the first problem 8 is assigned to you, and so what I'm going to do is I'm going to go through problem 7 and make a couple key observations here as we read the problem, and make sure it's clear what everybody, or it's clear to everybody what it is we want to try to do with this scenario. So let's see, a recent national survey found that high school students watched an average of 6.8 movies per month, with a population standard deviation of 1.8. That would be movies as well. The distribution of number of movies watched per month follows a normal distribution. A random sample of 36 college students revealed that the number of movies watched last month was 6.2. At the 0.05 significance level, what can we conclude that can we conclude that college students watch fewer movies a month than high school students? And so a couple things that before I get into this process here, let me just highlight a couple things here. The fact that we are dealing with a population standard deviation, which is given, and this key statement here that is going to help us in the first step of this test of hypothesis, and that is, can we conclude that college students watch fewer movies a month than high school students? So as you've gone through the reading, this is very, process driven. The first step in the process is to state the two hypotheses. H0 or H sub 0 is known as the null hypothesis, or what we believe to currently be true. And H1 is called the alternative hypothesis. And that is what we are testing about the scenario. I think in hypothesis testing, the most difficult thing to do for most students is to actually state the hypotheses. And it's just, it's really sort of an acquired skill. And it really comes about from reading these question statements very carefully and making sure you understand what it is that you are trying to show. I'm not going to say prove, but or what you're trying to validate statistically. And it's very clear in this last sentence that at the 0.05 significance level, can we conclude that college students watch fewer movies a month than high school students? So the alternative, or the null hypothesis, which will always contain inequality, we're going to assume that the current population mean is at least 6.8, and what we want to test is the mean based on our sample less than 6.8. So that addresses the null and alternative hypotheses. And again, the key thing to remember is when you state the hypotheses, excuse me, make sure that you have an equality in the null hypothesis. If you don't, there is really no basis for the test, because we have to assume to start the test or to conduct the test that we know something about the parameter. So as the solution here goes A through E, I have put some notes here for each A through E. So as I say, the key phrase is, can we conclude that college students watch fewer movies a month than high school students? So that's telling us that we're trying to test to find out whether or not the parameter is actually less than 6.8. The second step, excuse me, select the level of significance. So we know that alpha is 0.05. And in the reading, we talk about 1 and 2 tail tests. And you can tell whether this is a 1 or 2 tail test just simply by looking at the hypotheses. And because the alternative hypothesis is trying to test whether the mean is less than 6.8, then we know that this is a 1 tail left test. I'll talk a little bit more about that when we get down here to part D. So at an alpha level of 0.05, we know that if you look at the standard normal distribution, the value that separates the bottom 5% from the upper 95% is a z-value of minus 1.65. So we're looking for the test statistic, which I'll talk about here in a minute. We would reject the null hypothesis if the test statistic is less than minus 1.65, which corresponds with your level of significance of 0.05. So again, so to go along with part B, I say by inspecting the hypothesis, this is a 1 tail left test, and I explained that simply by looking at the alternative hypothesis. And with an alpha value of 0.05, the z-critical value is minus 1.65. Part C, this is really where you start your computations. The test statistic, identify the test statistic, which kind of goes along with step 5 a bit. The test statistic is, again, just a modified z-value or z-score that we know from many sections ago. And let's see. Because this is a sampling distribution, we know that the denominator is going to be the standard error of the mean in this case. And I say that is sigma over the square root of n, and that is because the population standard deviation of 1.8 is known. So the test statistic here, this will change as you go from a mean to a proportion. You will see some of that in the explanations in the book. So we have the test statistic here. Once we plug in the values, 6.2 is the sample. Let's see, sample mean was 6.2 movies, minus the assumed population mean of 6.8, and then 1.8, which is the population standard deviation, divided by the square root of 36. You compute that, you get minus 2.0 for your test statistic. Step 4, formulate a decision rule. So again, this if you use this rejection region idea, there's a rejection region approach and then the p-value approach, and we'll talk about both of these. If you look at this distribution and you consider it from a normal distribution standpoint with a mean of 0, we know that the z critical value, I don't know why I put 1.96. Let me change that real quick. That should be 1.65. I apologize for that. We can change that on the fly. That would put this line over here just a bit more at about minus 1.65. But then you see here is the rejection region. So anything with a z-value less than minus 1.65 would put it in an area where we have the last 5% of the distribution and the upper 95% of the distribution. And since your test statistic is minus 2.0, your test statistic falls in the rejection region. So when you state or when you take the sample and arrive at a decision, remember from the reading that there are really only two outcomes in the test of hypothesis. The first would be that you would reject the null hypothesis, and that is as a result of the test statistic falling into the rejection region, or by the p-value, which I'll show you here in a second. So because your test statistic does fall here in the rejection region, the conclusion would be to reject the null hypothesis. Would be to reject the null hypothesis and assume the alternative. So what we're seeing here is we're going to reject the fact that the mean is at least 6.8, and we're going to assume that it is actually less than 6.8 based on the sample. The other way to do this, it's discussed in the textbook, is by this p-value idea. And the p-value is effectively this. If I take my test statistic of minus 2.0, which would be right about here in the distribution, the p-value says what is the probability of a test statistic being less than minus 2. And I say less than minus 2, again, because we are looking for values of the test statistic which would be significantly smaller than minus 2, again, going back to the alternative hypothesis. And that, again, this kind of all goes together with the rejection region. So if you go into your table and you look for a z-value of negative 2.0, you will find that the area to the left of that is about 2.28%. So at negative 2, you're separating the bottom 2.25% roughly from the upper 97 and 3/4 portion of the distribution. So the associated p-value for a z-score of minus 2 is 0.0228. And the way that we would approach this from a p-value standpoint, as opposed to a rejection region, is we would simply compare the p-value of 0.0228 to alpha, which is 0.05. And since p is less than alpha, we would again reject the null hypothesis and assume the alternative. So regardless of which test you use, you will come up with the same conclusion. And in this case, you will reject the null hypothesis and assume the alternative. Let's see. I think I'm going to run out of time on this post. So what I'm going to do is I'm going to stop this one and I'm going to record a second one. It'll go much quicker, but I do want to talk about the work that you're going to do on these last two questions. So let me pause here and I'll post this, and then I will post a second one with these last two questions and sort of break this up a little bit.